Today we're going to be completing lessons 22 and 23. Our learning goal for lesson 22 is to find factor pairs for numbers to 100 and use understanding of factors to define prime and composite. Now we have some important math vocabulary in this learning goal that we need to define. First of all, the word factor. What is a factor? Factors are two numbers that we multiply to get a product. So for example, in the equation 2 times 3 equals 6, 2 and 3 are the factors of the product 6. Even when we have a larger equation, like 3 times 15 equals 45. The two numbers we multiply, 3 and 15, those are the factors of the product 45. Okay, so we know what factors are. You're going to be learning about the words prime and composite. And those have to do with the number of factors for any given amount. And then in lesson 23, we will use division. We won't so much be using the associative property, but we will be using division to test for factors and observe patterns in the factors of numbers. Let's get started. Prime numbers are numbers that have only two factors. Only two factors. The only way to make a prime number is by multiplying it by 1 and itself. So for example, the number 5. If we list the factors of the number 5, the only way to make 5 is 1 times 5. There are no other two numbers that we can multiply to get a product of 5. So that makes 5 a prime number. I'll give you another example. If we wanted to list the factors of the number 13, how do we make 13? 1 times 13. Is there any other way to multiply to make 13? 2 times anything? 3 times anything? No. 4, 5, nope. The only two factors we can multiply to make 13 are 1 and the number itself. That makes it a prime number. On the other hand, a composite number is a number that has more than just two factors. Take the number 12, for example. What are the factors we can multiply to make 12? 1 times 12, 2 times 6, 3 times 4. So that means there are 1, 2, 3, 4, 5, 6 factors of the number 12. So since there are more than just two factors, that makes 12 a composite number. Let's look at another example. If we take the number 4, what can I multiply? What factors can I multiply to make the number 4? 1 times 4, 2 times 2. So then what are the factors of 4? 1, 2, and 4. So since there are more than just two factors, 4 is a composite number. There's more than just one way to get that product. Let's do some practice. Turn to page 145 in your math workbook. We're going to list the factor pairs in multiplication sentences for each of these numbers. Then, when we list factors, we write them as a list in order from least to greatest. So from smallest to biggest. Then we're going to classify each number as either prime or composite. If we look at letter A, it's already done for us. So the ways to make 4, 1 times 4 equals 4, 2 times 2 equals 4. Now we list these factors again from least to greatest. So 1, 2, and 4. Now, how did we determine whether it was prime or composite? If there are only 2 factors, it's prime. If there are more than 2 factors, then it's a composite number. So when we look at the factors of 4, there are 3 factors in our list, so that makes it a composite number. Let's complete letter B. The number is 6. What can we multiply to get a product of 6? 1 times 6, 2 times 3, and that's it. So then, what are the factors of 6? Remember, we want to list them from least to greatest. 1, 2, 3, and 6. Since there are 4 factors here, is 6 a prime number or a composite number? It's composite because there are more than 2 factors. Letter C. What can we multiply to make 7? 1 times 7. What else? 2 times anything? Well, if we skip count, we'll see. 2, 4, 6, 8. Since we skipped over 7, 2 is not a factor. Are there any other ways to make 7 by multiplying? Nope. So then what are the factors of 7? 1 and 7. Since there's only 2 factors, 1 and the number itself, that makes it a prime number. Letter D. What can we multiply to make the number 9? 1 times 9. 3 times 3. And nothing else. So if we list the factors now from least to greatest, look at the numbers we multiplied. We have 1 is the least, 3. Now we use the number 3 twice here, but in our list, we only list it once. So 1, 3, and 9. There are more than 2 factors, so 9 is a composite number. Letter E. What factors can we multiply to make a product of 12? 1 times 12, 2 times 6, 3 times 4. That's it, so now we'll list them from least to greatest. Always start with 1, 2, 3, 4, 6, 12. The product 12 has 6 different factors. That makes it a composite number. Letter F. How do we make 13? Well, 1 times 13 for sure. And then that's going to be it. There's no other two numbers we can multiply to make 13. So the only factors in our list are 1 and 13. Since there are only 2 factors, that is a prime number. Letter G, 15. We can make 15 by multiplying what factors? 1 times 15. 3 times 5. And now that's it. So now we list them from least to greatest, starting with 1, 3, 5, and the greatest is 15. So there are 4 factors in our list. That means the number 15 is composite. Now go ahead and complete the remainder of the problems on this page independently. Once you've completed the problems on page 145, please turn to page 151. We're now skipping ahead to lesson 23. We're still determining factors of numbers, but now we're going to be dealing with larger numbers. So it is not as efficient to try to list all of the numbers or skip count when we have large numbers like 84, for example. So, in order to determine if a number is a factor of another number, what we're trying to figure out is if 2 is a factor of 84, that means that 2 times something would equal 84 if 2 is a factor. How do we find the missing digit in a multiplication equation like this? That's right, we do the opposite of multiplication, which is division. So what we're going to do is 84 divided by 2. And if 84 can divide into 2 evenly, then we know that 2 is a factor. So we're going to divide. (84) divided by 2. Our multiples of 2 we know are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. What's the greatest amount we can subtract from 84? 20. And 20 is equal to 2 times 10. Then we know we subtract. There's 64 remaining. We can subtract another 20, or 2 times 10. Now we're left with 44. We can subtract another 20, which is 2 times 10. Don't forget that step. We're left with 24. We can subtract another 20 from 24. I'm running out of room, but that's okay. Now I'm left with 4. Oop, but I forgot a step. Every time I subtract, 20 equals how many groups of 2? 2 times 10. Now I'm left with 4. What's the greatest amount from my list that I can subtract from 4? I can subtract 2 from 4, but I could also subtract 4. So I want to use the greater number. 4 equals 2 times 2. 4 minus 4 is 0. My quotient is, add this all up, 10, 20, 30, 40, 42. And do we have any left over, any remainder? No, because we have 0 here. So that tells me that 2 times 42 equals 84. Since that divides evenly, 2 is a factor of 84. Now, if we do the same for letter B, is 2 a factor of 83? That would mean that 2 times something evenly would have to equal 83. So we would complete the same steps here just using the number 83 instead of 84. So we're going to use 20. We're going to use 20 again. 20 again. 20 again. Now we have 3 left. What's the greatest number I can subtract from 3? The greatest multiple of 2 is going to be 2. 2 equals 2 times 1. Subtract. 3 minus 2 is 1. So what's our quotient? We're going to add up. 10, 20, 30, 40, 41. Do we have a remainder this time? We do, because there's 1 down here. So we get 41 with a remainder of 1. If we have a remainder, like we do here, that means that 2 is not, our answer is no, 2 is not a factor of 83 because it doesn't divide evenly into 83. So when we're using division to determine factors, if there's a remainder, the number is not a factor. If there's no remainder, like in the first problem we did, then it is a factor. So I'm going to erase this since I took up so much space. So our answers were yes and no here. To determine our next problem, is 6 a factor of 84? We have to determine if 84 divided by 6 gives us an even number with no remainder. Same thing for letter F.